All right, in this video, we're going to talk about how to locate yourself on the part. We're going to talk about the digital readout system, both the XY system that we have with the Sony and the Mitutoyo Quill digital readout. Anyway, when you come up to the machine and you turn it on, you'll see a display like this, and Sony should be blinking. And just come up and hit reset, and that kind of gets things alive. The digital readout actually has two modes, has incremental and absolute. Absolute mode is where you would be, let's say, at the corner of your part. Incremental mode would be any of those measurements you want to take from that point or between points on the part. And we use incremental mode quite a bit for finding the center of things, that sort of, and some other processes. But anyway, let's just take a look here. These two lights, right now it's in incremental mode. If I select the x-axis and push this button, it'll be in absolute mode. Y button and absolute mode. So the incremental, now it's currently in absolute mode. So if I wanted to find the edge of my part, for instance, I might go over to it and with an edge finder, we'll do that in a second, but on the X and Y, and then I'll push to set the edge for absolute mode. I'll push X, and then this datum button, and then Y, and then the data button. So that sets those two to 0. Now if I go back to incremental mode, X incremental mode, Y in incremental mode, they'll be zeroed out as well. Okay, because we're starting out there. So now we're in incremental mode. If I can move around, and I can, let's see, I'll move to a location. Let's move it to 375 by 250. This is really tricky here. This thing reads out at 2/10 of a thousandth. So anyway, 375 by 250, and I can set that as an incremental 0. So I can zero these things out. Now if I go back to absolute mode, then I can go, let's say if I want to go, move over an inch from this particular position. And go to 1 inch. And then, now if I go back to absolute mode, X, absolute, Y, absolute, you see it's quite a bit different numbers. All right, so we'll go back to incremental mode. That's these two lights up here to tell you what mode each of the axes is in. A lot of DROs, when you switch between absolute and incremental, it'll switch all the axes. So there's some benefit to this, some benefit to the other. So let's start taking some, let me go over a couple other things. Strangely enough, to go between inches and millimeters, you push the decimal point. You can see it switched to millimeters. Now it's inches. There's nothing to indicate which mode you're in, inches or millimeters. So you just have to remember and be careful with that. You can probably tell by the number of decimal points. There's 3 decimal points for millimeters, and there's 4 for millimeters. So let's actually take some measurements and see how this works. All right, here's our sophisticated drawing we have here. You can see that we've got this upper left corner as our 0, 0 reference on this drawing. This drawing is kind of weird because it has both ordinate dimensions and it has incremental dimensions. But anyway, let's say this is our 0, 0. So we can make this our datum point for our absolute. And you can see 1 inch down, we've got this line where we're gonna put these two holes. We don't have the type of hole, size of hole defined, but we'll come up with something. Also notice that this first hole is 1.25 inches to the right of our datum, and then these two holes are 0.625 inches apart. So we could just simply find this ordinate dimension by simply adding 625 to 1.250, But we'll show you how to do that a little easier using a digital readout. So let me mount a piece of material in the milling machine and we'll go from there. Okay, so let's start up here. We've got our fancy drawing. We've got our workpiece. So I'm going to put a couple parallels in the vise to lift it up a little bit. I'll set our workpiece in there and I'll tighten up the chuck a little bit and generally what you'd like to do is seat the workpiece so that the parallels are tight. That's pretty good. All right, so we need to first of all find this corner over here. So let's put a chuck in the machine. 1/2-inch collet. This chuck has a 1/2-inch stub arbor on it, so let's put this in there and tighten it up. And put in our edge finder. All right, let's bring it over close first. Bring this down. And I'm going to bring it down so it just touches the piece. That right there would be good. Start with the machine. So let's find the x-axis first. So I'm going to come over here and touch that till this thing is wobbling, see? It'll straighten out and it'll move. So bump over. That's where I want to be. Right when it bumps over. So at this point, this is the x-axis, so I'll do x, I'll do the datum point, so that's my 0 there. And what I'm going to do is test it, make sure. Yep, pretty good. So at this point, remember the edge finder has a diameter of 200 mils. So what I need to do at this point is raise this up. Be sure you remember to raise it up. I'll bring this over 100 thousandths. Right there, and do another. That's close enough. X, and then now that gives us, we're right on 0 there. So now we'll do the Y. Same process. Pretty much bring that down close, and we'll find that edge. Just bumps over. And I'll do Y and datum, and then I'm going to come back and check my work. Do it again. Just bumps over. Pretty good. Okay. Again, we have to compensate for the diameter of the edge finder. So I'll come in at 100 thousandths. Yep. There we go. Now, Y and the datum. So I can turn off the machine. So right now, if I were to move this back to 0 on the X, we'd see our device right over where we need to be, so that's good. And right now we're done with edge finder, so I'm going to take it out. And I guess we'll drill, we'll call those 1/4-inch holes. So I'll put a 1/4-inch drill bit in here. We're not going to do the center drilling and all that This is just for demo. So anyway, I'll just use the drill bit as it is. And what I want to do is come down this 1 inch on the y-axis, 1 inch. And we have to go over 1,250 thousandths. Or I'm sorry, 1.250. 0.25. There we go. And so that's the position of our first hole. I guess I can go ahead and drill that. Let's use a little bit of lubricant. Alrighty. So now we want to move over 625 thousandths. Again, we could add 625 to the 1.250, but let's do it this way. Let's go ahead and zero out this axis with a reset. That switches us automatically to incremental. It retains our absolute position. So I know it's 625, I go on an X. $625, and I can drill this next hole. Walks a little bit. Okay, so we got that hole drilled, and should be just in the right place. All right, now I'm going to try something a little different. I'm going to move over 1 inch from this point incrementally and make it a small hole. So move over here to 1 inch. And I'm going to put a hole right here. And this is, I can't remember, about an 1/8 inch drill bit. Go a little higher RPM. Okay. And I'm going to pull out this drill bit. I'm going to show you how to use it. You may have a device kind of like this. You have a cylindrical type device on one end, but on the other it's a cone. And I can show you one of the ways you can use this cone. Turns out pretty neat. And lock this up in the chuck. Lock it down nicely. And I'm just going to move this table to some random location. And then I'm going to try to come back and find that hole just by using the little cone device. I bring it down close to the work. And I'm going to steer the table over until I can set the cone in the hole. Now this requires that your hole have good, good sides to it. I mean, it can't be a real ratty hole, but and you notice that it sets this off. And what I can do in moving the table, you see that it is going to slide back and forth. And here I'm moving the y-axis right now. I'm putting my fingernail on that edge. And when it drops down, fingernail's very sensitive. Okay, x-axis, same way. I'm going to put my fingernail on the edge. All right, we look at our DRO. I'm off about 5 thousandths, 6 thousandths maybe, in the X, but pretty much right on in the Y. But anyway, that's a good way of finding location of holes. If you have an existing part, for instance, that has holes all over it and you want to be able to reverse engineer that, you can go back in and use this method. It's particularly good for people who have to work with circuit boards and that sort of thing, making mounts for circuit boards. They can go back and measure them very accurately. So yeah, that's one more trick for using that. All right, let's try another project. So we have this shaft here, and we want to drill an 1/8 inch cross hole, say 1/4 inch from the end. Say this might be for kids' sidewalk racer or something. So I'm going to use a couple of V-blocks to hold the part and put it out there. V-blocks are precision ground, so you can really do some precise work with them if you want. I'm just going to set them all the way down. You could put them on parallels, but it's a little easier to just put them all the way down. But what we've got to do is determine, first of all, where 1/4 inch is from this end, and also where the center of the shaft is. So to do that, of course, we use our trusty edge finder. And let's see what we do here. Hold on. And first we'll find that the end of it. Now, I can move over, so let me do a reset first. So on the x-axis, I'm just going to reset. We'll stay in incremental mode. I could move over 1/10 of an inch and then move over another 250 thousandths for the 1/4 inch. But let me just move over 350 thousandths. That's easier. So, that's pretty close. Within 2/10, I think that'd do. I'm going to lock the table, and now I need to find the center. So how do you find the center? Well, on the y-axis, I'll come down here, and I'll make sure that this is that the bottom of this is a little bit past center, and I'll find this edge. Oh, there it is, right there. Back up again. There it is, right there. So I'm going to do a reset on the y-axis and come over here and go to the other side. And do the same thing. Find this edge. Always remember to lift that edge finder. It's so easy to forget to lift it, and then you crash it and break it. So, all right, there we go. Now, this time, what I'm going to do is I'm going to press Y and this little center line figure right here, and that will automatically divide that distance by 2. So when I come back to 0 on the Y, it also puts it in incremental mode when I do the reset. I'll come back to 0 here. It would be right on center. And I can lock the Y too. All right, now I can drill my hole. You know, whenever you're drilling holes on round things like this, it can be really tricky to drill a walk. So what we do is we use a center drill. These are actually made for cutting centers on the lathes, but we're using a milling machine just for this purpose as a starter. So I can put a little lubricant on there. Always a good idea. The center drills aren't a real efficient drill. And because of that, they're easy to break. They don't have a twist to remove the chips, so this is just making it, I'm almost hitting the, bring that up, and use a little brush to brush the chips off. Now we'll come back with our finished drill. This is the 1/8 inch drill. There we go. There's our hole. Right through the center, no problem at all. All right, you saw how the center worked on the last part, just drilling a hole in the side of a shaft. It worked pretty good. We can also use it for some other techniques. And suppose we have this round object here, and our assignment is to drill a bolt circle in the top of say 5/8 of an inch in diameter, and it has to be centered on this outside edge. So we'll go ahead and mount this in the vise, and going to use a V-block. It's a good way of handling round stuff. Make sure it's nice and straight, and tighten her up a bit. Alrighty. Now, so what we need to do first is find the center of this device. So we put a edge finder in there, snug it up, and I'm gonna bring it down. I'm just kind of eyeball center on the x-axis. It's got to be. It should be close. Closer the better, but it doesn't have to be right on at this point. So I'll go about there, and let me find this back edge first. There we go. So we moved the y-axis, so I'm going to do a reset on the y-axis. Raise this up so we don't break it off. Bring it on over. And again, bring it down. So we can pick up this other edge. All right. Okay, that's that edge. What I'm going to do now, come over to the DRO, the y-axis, and then center line. Now bring this to center. So we found the center on the y-axis. I'm going to put it right on center. Pretty much. And then we'll do the x-axis same way. You can do either side. I'm going to do this side first. And I'll bring it in there. It just pops over. We're moving the x-axis, so I want to do a reset on the x-axis. Raise this up. We go to the other side. And do the same thing. Pops over. Back up a little bit. Pops over. And I'll do an X, and then again the center line. So when I bring this point, if I bring X to 0, we'll be right in the center of our part. Pretty good, huh? So now if we want to drill, we're going to make it easy on ourselves, we'll drill a 4-bolt circle. We could do almost any number you want. It's just a matter of doing a little trig and figuring out the XY coordinates. Now, the easy thing to do is to look it up in the machinery handbook. And I think even our machinery handbook here is even dog-eared for that. So you can say, okay, I want to do 5, and it will give you a multiplier for the radius and XY coordinates using that multiplier. Anyway, so I'll just come up here, 3, 1, 2. I'll just spot the holes, but we'll just give you an idea. 3, 1, 2, 5, actually 3, 1. That's pretty good. So I would try not to tighten that. So I'd set one there. 1, 2, 3. One there. And set this at 0. Set one there, and set one there. You notice I use the brake quite a bit. It really saves a lot of time, and really rather not have your hands down here too much when it's running. Okay, so look at that. Is that good or what? So it's easy to set up. You could do, like I say, you can do 3, 5, you know, how many ever you want. But finding the center of a round object. Now this works just as good when you're doing a hole. With the center, with this edge finder, you could be inside the hole. And doing the same way and find the center of a hole, so you can work around that. And anyway, so that's pretty much it for this video. I'm kind of try to keep it a little short, and we'll keep on working on this stuff at the Maker Barn. And thanks for watching.